It was a holy moment, one that marked a significant shift in our understanding of the cosmos. The Andromeda Nebula, which was once merely a smudge of light in the night sky, overnight transformed into the Andromeda Galaxy. This profound revelation, brought to us by the incredible advancements in astronomical technology, was made possible through the James Webb Telescope. This extraordinary instrument has identified 6 galaxies that formed a mere 500 million years after the Big Bang. It's a discovery that pushes the boundaries of what we previously thought was possible. When you gaze up at the night sky, that tiny, seemingly insignificant pinpoint of light takes on a whole new meaning. Through the lens of the James Webb Space Telescope, that pinpoint of light expands into breathtaking images, revealing the vastness and complexity of the universe. Our universe is continuously expanding, stretching beyond what we can fathom, making it a challenge to establish its limits or measure its full size. However, thanks to the incredible capabilities of the James Webb Telescope, we can now peer into the farthest reaches of space, giving us a glimpse into the universe's deepest corners. Since the James Webb Telescope began its exploration, scientists across the world, including renowned figures like Brian Cox, have made stunning announcements about the sheer size and vastness of the universe. It's a scale that is almost beyond comprehension. Within the fragment of the universe that we can observe, scientists estimate there are approximately 2 trillion galaxies. This mind-boggling estimate is based on detailed studies of our local universe, but even with this knowledge, we are certain that the portion we can see is only a tiny part of what could be an infinite universe, an expanse so vast that we have yet to fully understand it. We are not separate from this universe, though. Rather, we are an integral part of it. In a poetic sense, humanity is the universe attempting to understand itself. As we use the James Webb Telescope to explore the cosmos, we embark on a monumental journey to discover the true size and nature of the universe. This exploration is not just a scientific endeavor but a philosophical one, encouraging us to reflect on our place in this immense, ever-expanding cosmos. If you are fascinated by the universe and want to stay updated on the latest discoveries, consider subscribing to our channel, where we regularly share news about space and its wonders. Be sure to like this video and turn on notifications so you don't miss any future updates. To put things in perspective, if we were traveling at a speed of 70 miles per hour, it would take us about 15 days to complete a single lap around the Earth's equator. However, the journey becomes exponentially longer when we scale up. It would take approximately 5 months to reach the Moon, 63 years to get to Mars when it's at its closest point to Earth, and an astonishing 4,400 years to reach Neptune. These numbers illustrate the immense scale of our solar system alone. Even these enormous distances pale in comparison when we consider the vastness of the universe beyond. One way to further appreciate this scale is by looking at the Voyager 1 probe, which was launched in 1977. Traveling at a speed of 38,000 miles per hour, Voyager 1 did not leave the boundaries of our solar system until 2012, 35 years after its launch. This probe's journey underscores just how vast our solar system is. Even light, which can circle the Earth 7 times in a single second, seems slow when we consider the immense distances between celestial objects in our solar system. Yet, despite its enormous size, our solar system is but a tiny speck within the Milky Way galaxy. The Milky Way contains approximately 300 billion stars, each of which likely has its own planetary system. Our nearest stellar neighbor, Alpha Centauri, is 4.3 light-years away. If we were somehow able to travel at the speed of light, it would take us 4.3 years to reach it. But traveling at the speed of Voyager 1 to 38,000 miles per hour, it would take a mind-boggling 70,000 years to make the same journey. This incredible figure drives home the unimaginable distances involved in interstellar travel. Let's shift our focus now to Vega, a star located 64 light-years away from us. Vega holds a special place in astronomical history, as the light we see from it today left its surface about 640 years ago. That's 100 years before Columbus set sail for the New World. The thought that this light has traveled through space for all that time, only to now reach Earth, is truly awe-inspiring. Even more astonishing is that, on a universal scale, Vega is considered relatively close to us. To add to this wonder, we must consider the concept of the radiosphere, which represents the distance our radio transmissions have covered over the past century. While these signals have degraded significantly over time, they have still reached about 15,000 star systems. However, when we compare this figure to the total number of stars in the Milky Way, around 300 billion, we realize that our reach is but a tiny fraction of what lies out there. And when you look at Vega tonight, you're seeing light that embarked on its journey centuries ago, a visible reminder of how vast and interconnected the cosmos truly is. But the immensity of space doesn't stop at our galaxy. Beyond the Milky Way, there are an estimated 1 trillion more galaxies. This number is so vast that it's almost incomprehensible. To understand a trillion, think about it like this: imagine a collection of 1,000 cats. Now picture 1,000 groups of these cats, each consisting of 1,000 cats. That would give us a total of 1 million cats. But a trillion takes this to another level. It's a million multiplied by a million, an almost inconceivable number. Our nearest galactic neighbor, the Andromeda Galaxy, is 2.5 million light-years away. What's even more fascinating is that Andromeda is rapidly approaching us at tremendous speed. As it draws nearer, the night sky will undergo significant changes. Andromeda contains about 1 trillion stars, and when it eventually collides with our Milky Way, home to 300 billion stars, the likelihood of individual stars from the two galaxies colliding is actually quite slim. This is due to the vast distances between stars, which illustrates just how empty space truly is, even within galaxies. Galactic collisions, though rare on the scale of individual stars, may play a critical role in the evolution of the universe. Such collisions can even facilitate the transfer of life between stars and galaxies, as galaxies are not static but dynamic and constantly evolving. Moving beyond our galaxy, we encounter our local group of galaxies, followed by the Virgo cluster, which contains more than 1,500 galaxies. Virgo is part of an even larger structure, the Laniakea supercluster, which houses approximately 100,000 galaxies. Each of these galaxies contains billions of stars and planets, yet even this massive number is just a small part of the observable universe. As we zoom out, we begin to see the universe as a grand tapestry woven together by cosmic structures. Beyond the observable galaxies, there are hundreds of billions more, many of which have not yet been fully mapped. This vast number of galaxies is mind-boggling, and even as we map more of the universe, we realize we have only scratched the surface. In addition to galaxies, the universe is filled with fascinating phenomena. Supernovae, for example, are the explosive deaths of massive stars. These explosions disperse heavy elements throughout the cosmos, enriching the interstellar medium and planetary systems. Black holes, with their immense gravitational pull, play a pivotal role in the evolution of galaxies. They can release powerful jets of energy that stretch across great distances. In the depths of space, we also find quasar, supermassive black holes that consume nearby matter and emit colossal amounts of energy. These quasars serve as beacons, allowing us to study the early stages of the universe. As we delve further into the cosmos, we begin to question what lies beyond the observable universe. There are additional galaxies whose light has not yet had time to reach Earth. Due to the universe's continuous expansion, the light from many of these distant galaxies will never reach us.